Imagine a time before smartphones, before cars, before electricity. A time when the world was a vast, untamed wilderness, and human beings were just beginning to understand their place within it. Journey back to a time when humans first transitioned from wandering nomads to settled farmers. This monumental shift marked the dawn of agriculture, a revolution that would forever change the course of human history. This period, around 4000 BC, saw the rise of civilizations in Mesopotamia, the land between two rivers, the Tigris and the Euphrates. These rivers provided fertile soil, enabling the growth of crops and the establishment of permanent settlements. Here, in present-day Iraq, the Babylonian civilization flourished. The Babylonians built impressive cities, developed complex societies, and created a rich cultural heritage that still fascinates us today. They left behind an indelible mark on history. Their contributions to art, literature, and science have been studied and admired for centuries. Their innovations weren't just in agriculture and governance. They developed sophisticated systems of irrigation, enabling them to cultivate the land more effectively and support larger populations. The Babylonians were pioneers in mathematics, shaping the very way we understand numbers and their relationships today. Their advancements in algebra and geometry laid the groundwork for future civilizations to build upon, influencing the development of mathematics throughout history. Picture a clay tablet. Now imagine using a sharpened reed to etch symbols into the wet clay. This, my friends, is cuneiform, the writing system of the Babylonians. It was more than just a way to record language. Cuneiform became the tool with which they inscribed their mathematical discoveries. These tablets, thankfully durable, survived millennia. They offer us a window into the minds of these ancient mathematicians. We see their methods, their thought processes, their breakthroughs. Think about our modern timekeeping. 60 seconds in a minute, 60 minutes in an hour. This system, which we still use today, is a direct inheritance from the Babylonians. They used a base 60 or sexagesimal system. Why 60? It's a highly divisible number. This makes it ideal for calculations involving fractions. The Babylonians could represent fractions like 1/2, 1/3, 1/4, and 1/5 with ease. This system, elegant in its simplicity, had profound implications for their mathematical advancements. The Babylonians weren't just content with basic arithmetic, they ventured into the realm of algebra. Imagine trying to solve an equation like x squared plus 10x equals 39. The Babylonians developed sophisticated methods to solve such quadratic equations. They used a system of tables and algorithms. These enabled them to find solutions with remarkable accuracy. Their understanding of quadratic equations was sophisticated. It laid the groundwork for further algebraic exploration by later civilizations. Section 5. Ancient Pythagoras. Babylonian Influence. We all know the Pythagorean theorem, a squared plus b squared equals c squared. This theorem is a cornerstone of geometry, taught in schools around the world. This fundamental principle of geometry relates the sides of a right triangle, providing a method to calculate the length of any side if the lengths of the other two are known. It's named after the Greek mathematician Pythagoras, who lived around 570 to 495 BC. Pythagoras and his followers, known as the Pythagoreans, are credited with many mathematical discoveries. However, evidence suggests that the Babylonians understood this concept long before Pythagoras. Their civilization thrived in Mesopotamia, in what is now modern-day Iraq, from around 1894 BC to 539 BC. Clay tablets dating back to 1800 BC contain calculations and diagrams related to right triangles. These ancient artifacts reveal that the Babylonians had a sophisticated understanding of mathematics. These tablets provide compelling evidence that this knowledge predates the Greeks. The Babylonians used a base 60 number system, which allowed them to make precise astronomical and mathematical calculations. It highlights the possibility of intellectual exchange between these ancient cultures. The transmission of knowledge across civilizations is a testament to the interconnectedness of human history and the shared pursuit of understanding the world around us. Section 6. Clay tablets and celestial maps. Astronomy in Babylon. The Babylonians were keen observers of the night sky. They meticulously recorded the movements of stars and planets. Their observations, meticulous and detailed, were recorded on clay tablets. These astronomical diaries spanning centuries allowed them to identify celestial patterns. They developed a sophisticated understanding of lunar and solar eclipses. Their observations laid the groundwork for the development of astronomy as a science. Section 7. Engineering marvels, from Ziggurats to Canals. The Babylonians were renowned builders and engineers. Their cities were marvels of ancient urban planning. At the heart of each city stood the ziggurat, a massive stepped pyramid topped with a temple. These structures required advanced knowledge of geometry, mathematics, and engineering. The Babylonians also constructed elaborate irrigation systems. These canals and waterways tamed the unpredictable Tigris and Euphrates rivers. Their engineering achievements were a testament to their practical application of mathematical principles. Section 8, a legacy etched in stone: Babylonian influence. The Babylonian civilization may be lost to the sands of time. However, their mathematical legacy endures. Their innovations in arithmetic, algebra, and geometry laid the foundation for later civilizations. The Greeks, who are often credited with the birth of Western mathematics, were undoubtedly influenced by Babylonian knowledge. Through the Greeks, Babylonian mathematical ideas spread throughout the ancient world. Their impact on the development of mathematics cannot be overstated. Section 9. Conclusion: the echoes of Babylonian genius. As we delve into the annals of history, the brilliance of the Babylonians stands out, echoing through the corridors of time. The next time you check your watch, remember the Babylonians. Their innovative base 60 system, which they devised thousands of years ago, is still with us today, subtly influencing our daily lives. Their base 60 system is still with us. This numerical system, which might seem archaic, is the foundation of how we measure time, angles, and even geographic coordinates. Their contributions to mathematics are woven into the fabric of our modern world. From the complex equations that govern our technology to the algorithms that drive our digital age, Babylonian mathematics is ever present. From the algorithms that power our computers to the principles of engineering that shape our cities, the Babylonians laid the groundwork for many of the advancements we take for granted today. The echoes of Babylonian genius resonate through time. Their intellectual pursuits and discoveries have transcended millennia, influencing countless generations and civilizations. They remind us that even in the distant past, human minds were capable of extraordinary intellectual feats. The scholars of Babylon were pioneers, pushing the boundaries of knowledge and understanding. Theirs is a legacy that continues to inspire and shape our understanding of the universe. As we look to the stars and explore the vastness of space, we are reminded of the Babylonians' contributions to astronomy and their quest to comprehend the cosmos. Their legacy is a testament to the enduring power of human curiosity and intellect, a beacon guiding us as we continue to seek knowledge and understanding in an ever-evolving world.